And yeah, just a second. I want to check whether the audio is all right. Okay, so we have fast track here. Huh. And I will check the sound. Is there sound? Yeah, sound is there. So yeah, Fusion 360. So I hope that all of you got it on your computers. And what we are going to do with it, we are going to build a simple project. So I'm going to demonstrate some features. So basically what I would like to do as an example project is to build like a simple case for this one, which is like a really basic electronics project that I usually show whenever somebody wants an introduction to electronics. So I'll show you probably something similar in the electronics design week, so with CAD, so maybe not so simple, but a bit more like one level up. Yeah, just to record it. Record. Yeah, so this is the board that we are usually making as electronics introduction. And today with Fusion 360 we are going to design a case around it. So let's open up Fusion 360. So here I'll probably have like one problem with it again. So yeah, the menu, the create menu is somehow displaying on the other screen. I don't know really how to solve this. But usually you start out by creating a sketch. But yeah, before that, I think I will mention some things with the preferences. So here you should make sure that you have like the default modeling orientation is set up. So because it's going to make it easier for you also to configure the CNC toolpaths later and kind of integrate the design with the manufacturing workflow. Then you should also make sure that you're working with the millimeters. But I think that, so it's under units, default units, millimeters. So everything should be set to millimeters because we are in Europe. And then so let's make a new project, not a new folder. No, like so the thing with Fusion 360 is that everything is being saved on the cloud. So you can export the projects also, so you can save them on the desktop. But the problem is that so you will not be able to use Fusion 360 if you're not connected to the internet. And so as students from the university, you can get the free license. So it's going to be for 3 years or so. And then Fusion is also offering a startup license. So if you're a startup or a small company or design individual, then you can get it also with a discounted price or for free, I think for free for 3 years. But then it's also like a mercy. So like Autodesk is kind of allowing you to do it like that, to get the software like that for now. So you don't know what is going to happen in the future. So maybe the software is going to get better and more powerful. It's going to kill the competitors. And at some point they are going to raise the raise the bar, and you don't know what's gonna happen. So, but in the lab workflow here, it's very useful. So you can do most of the things. So this is why I think it's a good way to start, because it's gonna make a lot of things easier for you. Then, if you're up for the challenge, then you can try other software like FreeCAD. So I actually would like to teach FreeCAD instead of this. But yeah, let's get started. So it's important to choose a software for your tasks that is parametric, meaning that there's a centralized place where you can actually add and change parameters. So in Fusion 360, this is this place. So when you go to Modify, it's the Change Parameters section. So you click on that, and you get a window like this. And there's a section called User Parameters, and this is where you can add yours by clicking on the plus. And so let's start with something obvious. So from the board. So if you take a look at the board, then so it has a certain width, so it has a height, so it has a thickness. So the components also, they have some certain dimensions, but we are going to basically focus only on the board and maybe on the biggest elements on it, so which is the battery and then the button over here. So when we measure those, so the width of it, or size, let's say board size along x-axis is 50 millimeters, and then, oh no, wait, board. It's 50, and then board size along y-axis is 20, and then the thickness of it, or board size z, is 1.6. So the reason why I'm choosing these names is because I have used Fusion 360 before, meaning that it's much easier to map these names to the actual coordinates in the Fusion 360 coordinate system. So instead of talking in terms board width, board height, and board depth or whatever, so you just specify the actual axes that are corresponding to these values. So it's you're less likely to mess things up. So because human language is sometimes not so structured and not so it doesn't map so well with the CAD or programming environment. So I think this is like a nice middle point, in between point that I found. So in terms of naming, in programming, in my opinion, the most complicated part is always how you name your variables. So you have 10 variables. So how do you name them, and how do you make the names so that they are actually nicely descriptive, so that you can actually tell what kind of variables they are. So the same goes for CAD and parametric modeling. So once we have these, we can start doing things. When I click on Create, so there's a menu that is opening on the other window for some reason. It's making things a bit more complicated. Can I edit this menu? So Create, and oh man, I'm gonna pause the streaming and rearrange this a little bit. Nice. So here, when you click on Create, you can start with creating a sketch. And to create a sketch, you need to choose a plane. So I'm going to choose a plane in between X and Y axis, like this. So that I can pan with the middle mouse button. And usually what I do is specify a rectangle. And if we want to have fillets, then I right away create the fillets. And for the fillets, it's nice to know corner radius, which is going to be 3. And actually, at this point, I realized that it would be a nice idea to make it as a parameter. So I'm going to move one step back. and go to modify and add a parameter, which is going to be corner. So board corner radius, which is going to be 3 millimeters. So let's go add the fillets over here. So I'm adding the fillets now because when I will add more constraints, then it's going to be more complicated to keep it all organized. So after adding the fillets later. So here, the good thing is that as parameters, you can use these variables right away. So it's, you know, when you start typing, so it's going to refer to the parameters that we add in the parameters pane, and you'll be able to cherry pick the parameter that you actually want to use. In this case, it's board corner radius. You hit enter, and it's going to take the value that's hidden behind that and put it in there and use it as a value for the feature. Then I'm going to add some construction lines to be able to center this drawing into the into the center of the screen, or around the coordinate axis. So that's going to make it easier to make symmetrical things with the design. So I'm going to select line, and when I hover any of the lines in the design, so you'll see that at some points there's so the cursor is snapping and a triangle appears. So this triangle usually in CAD software means that it's the midpoint of something. In this case, it's a line. So I'm going to start to draw a line from the midpoint of this top line to the midpoint of the bottom line. Then I'm going to select it, and I'm going to turn it into a construction line here. Then I'm going to select the line tool again, and I'm going to select the midline of this one and draw a line to one of the edges, and going to snap to the midpoint of it as well. So like this, construction. And now, so once, I could also avoid drawing this line, but it's nice to have this line because at some point we can use this as a midline for something, so to mirror things around. So this is also why this line is kind of useful. And what do we want to do? We want to so it created this point also here, and we want to snap this point to the center point of the axis over here. And for this, we are going to use the constraints. So from yesterday's lecture, you remember that there were, so Neil was talking about the fact that, so these CAD programs, they usually have solvers. So instead of representing things by absolute and relative coordinates in the design, so this software more like uses relationships in between objects. And then the solver is taking these relationships and aligning the objects based on these relationships. So of course, like absolute and relative coordinates are part of those, but then there's much more. So as for example, for me, I remember that in the geometry classes when I was studying mathematics in school, so there were all these geometry things, like when lines are parallel to each other or perpendicular to each other, or there's an angle in between, or there's a tangent, or like whatever, then I was usually confused, and it wouldn't be so easy to map all these things to reality, or you wouldn't really see how these things would be useful in everyday life. And then I started to learn Illustrator, and none of this was there. So even though it was a software that would deal with geometrical objects. And then I think it was a bit more than 5 years ago when I first started to use CAD software or Fusion 360. And all of this was suddenly there. And I realized that it's actually useful. And there's so much more here than it was in the geometry lessons. So this is probably all the things that you would talk about when you're studying engineering, and I think like mastering these tools is also kind of a good way to learn engineering. I think that if you're having an engineering studies, then maybe trying to learn 3 different CAD tools is it's basically giving a good overview of what is possible with engineering. So, but yeah, I just like the concept of constraints. So in order to snap these 2 points together, we can use a constraint as well, so which is called the coincident constraint. And it's going to take 2 elements and coincide and make them match in the design. And now what we get here is that whenever we stretch the object, it's going to stretch in a symmetrical way. So because so this point is in the middle of this line, then so this line is exactly half the length of the width of the width of the object. And then another important concept in these kind of CAD sketches is that you should always aim for constraining the object as much as possible. So, and in Fusion you can tell that the sketch is constrained if a lock icon appears here in the project browser. So, and at the point it's not there because you can still freely move it. So since this design is based on relationships and constraints, so okay, like Fusion is going to save these coordinates and the width and height of the object somewhere in its file when you save it, but then you can never be sure that some other things that you do in the future steps, in the next steps of the design, that these are not going to change the sketch. So basically, if you do not specify the exact if you do not specify the exact sizes or dimensions of the object, Fusion can actually do whatever with your design, and you are not going to be able to be sure about the final outcome of the design. So in order to add dimensions, you go to create sketch dimension, and you select 2 objects or an angle in between lines. And here also you can use the parameters that we defined earlier. So board, so now board size Y, find the height of the board, and then board size X to define the width of the board, like so. And at this point we can finish sketch, and as you see also next to the sketch icon, on the sketch icon, you can see this little lock icon. And now when I hold down Shift and move the mid mouse button, I'm able to rotate it, to pan around the object, like so. And now I'm going to use the extrude or create extrude feature in order to extrude it. So you can extrude it manually like so, or you can also use a parameter, in our case the board size Z, like so. And I think a good thing to remember with Fusion is that you shouldn't make your sketches too complicated, because there's going to be always a possibility to make a new sketch on any of the future features of the object. And if you will need some reference or some projection from the previous sketch or the object itself, you will be able to add it to the new sketch very easily. So what we would need here, so what we see here in this board is that so we have holes, so we want to add these little mounting holes there, and to do that we'll need to add another sketch on the top of the object. So I'm going to create a new sketch and select the top of the object as the sketch plane. If you accidentally move it around and rotate, then I usually use this button here, so the top button on this little cube in the corner. So it's going to snap to the top view of the sketch, so the orthographic representation of it. And here, in order to reference the underlying design, so we can go to create and select the project include project. Thank you. So the project option. And then we can select the top surface of the board. And so you make sure that you are targeting this project pane over here, and you hit OK. And what it's going to do, so what it just did is it imported all the points and the lines and the curves that are representing the underlying object, and we can now use these points and lines in order to build our design on top of it. So what do we want to do? We want to offset, so we want to add a circle or a few circles and offset those from the edges of the object. In order to be precise, so there are some parameters that we will need. So I want to define how far this circle is from the edges, so from the top and the bottom of the, so from the corner, and then also I want to define the diameter of the hole. And I'm not going to do it with regular dimensions. I want to use parameters always, so I can change all of that in one place later. So I'm going to go to change parameters again, and I'm going to enter board hole diameter, and I'm going to add 2 as the number. So here you probably want to know what is the diameter of the screws or the mounting elements that you want to use. So they're usually 2 or 2.5, sometimes bigger. So yeah, but you need to make sure of that. So in this case, I will choose that it's 2 millimeters. Hit OK. Then add board hole. I'm going to call it offset. And add 2.5. Hit OK. So 2 new parameters. We'll hit OK. Now I am going to add a few lines that I am going to turn into construction lines. So I selected them through by pressing down, by holding down Shift and then selecting the lines. It's always a good idea, so before selecting a new tool and drawing something, to hit Escape and then choose the Select tool in order to select the elements. And then now, so for these construction lines, I want to define their lengths. And here, I'm going to choose the board hole offset. And I'm not going to give a dimension to this one, but I'm going to use the equal constraint to make these two lines equal. So this equal this one, like so. Now I'm wondering, so now you cannot move, it's nicely constrained. And now I want this point to match that point, so that it's actually, so that the circle is in the exact position. So I'm gonna use the coincident constraint. And lastly, I want to add a dimension, which is going to be the diameter of the hole, like so. Yeah, there are many ways how to repeat those and to make the holes. So for now, I'm just going to leave it as it is and demonstrate some ways how you can avoid adding too many sketch objects here. So what I'm going to do is I'm going to turn this into kind of a drill. And so when we created this object, then we saw a way how we can add mass or add volume by extruding, but extrusion can also remove volume, like so, cut through the material. But in this case, we are not going to cut right away, so we are going to create a new body. So that is going to directly represent kind of a thing that we are, yeah, like a drill that is going to drill through the board in a way. So we're going to create a new body. And then for the extent, we are going to define the object. So we are going to select the bottom of the board as the extent. So that whenever we change the thickness of the object, so the height of the cylinder or the drill is going to change as well. So, and then I'm going to hit OK. And now under bodies here in the browser, we see two bodies. And since we have two, we could actually name them. So we are sure we can also select those without looking at the visual part. And before we actually drilled it or punch the holes, we could mirror those. We could mirror the drill over the axis. So in order to mirror it, we can go to Create, Mirror, and so we want to target bodies. So we select the bodies that we want to mirror. So the drill and then the mirror plane. So once we select the selection box of the mirror plane, so the origin planes appear. And this is why it makes sense to start building your object around the origin, or around the zero axis and the zero planes of your workspace, because then it's going to be much easier to figure out how to mirror and symmetrically place things. So for the mirror plane, I'm just going to choose the default plane that was already there and hit OK. So now we have two objects here, so drill and drill one. And now we can go to Create, Mirror again, and for the objects that we want to select bodies. We can select these two. And for the mirror plane, we're going to select the plane between Z and X axis. And here we go. So all the holes are here. And now to actually drill the holes, we can go to Modify, Combine. Target body is going to be the board. You can select it here, or you can also select it from the browser directly. And the tool bodies are going to be the drill bodies here. So also you can select those visually or from the menu. Now, so the default operation is join. We want to change that to cut. And sometimes it is useful to keep the tools. So if you want to keep the objects, so the drill objects, then you would check the keep tools checkbox. But in this case, we don't need those. So we hit OK and have a board with holes.
What's the benefit of doing it this way instead of doing it in the sketch and then extruding?
I think in my case, it's more like the previous experience with it, that sometimes when you add it in the sketches, then it can get messy. But if you look on the bottom of Fusion here, so this history line over here, so it makes it very easy for you to control the design later. So you can go over to each of these features and you can change things. Basically now I think the issues that I would have like 2 years ago with this, they would be gone. And you could also do it in a sketch. But then the more complicated design, I think it makes more sense to split it in smaller, easily manageable parts. So if you do everything in one sketch and then try to build things out of this one sketch, then things can quickly become messy. But this, so far I have discovered that this is one method, like my favorite method of doing these things like this. But it's really up to you. So if you feel that mirroring in the sketch makes more sense for you, then it just makes more sense for you. I cannot argue with that. So there are some other elements on the board. So the battery holder and the button. So I'm not going to go into too much detail, and I'm not going to... Actually, the LED, it would make sense to add that. I'm probably going to skip the resistor part, but yeah, let's add the approximate volume for the battery holder and the button and the LED. So let's start with the LED. and add some parameters for that. So the space that the LED occupies along the y-axis is 6.5. And then the space it occupies along x-axis is 3 or less. 2. It's 2 millimeters. And the height of it I'm going to put 1.5. And the distance from the edge is like 2. Like so. Then I'm going to create a new sketch here, and I'm going to create a projection of the underlying object here, the design. Then I'm going to create a midline from here to the other edge over here. Select it, convert it in a construction line. Then I'm going to create a rectangle. I'm going to give some dimensions. So here it's going to be the LED size X, and then LED size Y, like so. Here also I'm going to create, so this time I'm going to create a point in the middle of this line here. And then I'm going to align this point to the midline of the sketch by using the coincident constraint, like this. So now what we have is that we can move this object freely, so it doesn't change the dimensions because it's a constraint. And we need a distance. Lastly, we need to add the distance between the right edge and the actual object. So let's add the LED offset, like so. And now we can finish sketch, extrude, and enter LED size Z as the value. And let's create it as a new body. Okay. And let's call it LED. And let's do the same with the button. So create sketch. And we are going to add some parameters here. So let's measure those. So it's 6.5 along Y. Then seven along X. And then the height of it is going to be 3. Okay, we have those. So, and now again, so we can go project and project the underlying design. Okay. Then add a midline, turn it into construction line, add a rectangle, and go create a dimension, button size X. Button size Y. Again, I'm going to add a point over here in the middle. Select the selection tool, select the coincident constraint, select the point and the midline, and finally create a sketch dimension between this point and the edge. And I think I forgot to add a parameter that would define that, but it seems to be 8.5. I'm gonna go and change the parameters. So button offset 8 point, like so. Finish. Then click on extrude and use the button size Z as the extrusion amount and create a new body. Hit OK and rename it to button. And lastly, we want to create something that represents the battery. And so there is, I'm gonna avoid some things here. I'm wondering what would be the best way to do it. I'm just gonna add a circle in the size of the battery and maybe a rectangle. So let's add some parameters first. So modify, change parameters, add battery size Y. So we are using 2032 battery, so 20 stands for 20 millimeters in diameter and 32 stands for 3.2 millimeters in thickness. So we can enter that. So battery size Y is 20. Battery size set is 3.2, but I'm going to add on top the holder. So together with the holder, the battery is 4 millimeters. Okay, and then so I'm going to enter the width of the battery holder, which is 21.5. Hit OK. Then also the offset from the edge, and it is 5. 5, okay. And yeah, let's continue with creating a sketch again on the top plane. Then again, I'm going to create a midline. Select the midline, make it construction line. I'm gonna add a circle in a random location. Then I'm going to add a dimension to it. Oh, not dimension between the line and the circle, but I just want to add it to the circle. This is going to be the battery size Y. So I'm gonna move it a bit off here, and the battery size X is more like a square. And for this one, I'm going to use the battery size y. So the thing here is also that you can do mathematical operations in these value fields or parameter fields. So I'm just going to divide this by 2, just not to make it relative to an existing parameter, not like a fixed value. And then this I'm going to turn into battery size x. And I'm going to make a midline, turn it into a construction line, then create a point, put it in the middle here, then select that point and make it coincide with the center point of the circle, like so. And then now I want this point also to coincide with this line over here. And now I can move it freely like so. Now I can define a distance between this and this. And it's going to be the offset. Like so. And now I'm going to do 2 extrudes. One is going to be for the battery. No, I could just actually extrude it just all, because I defined one size for the battery along the z-axis. And instead of joining, I'm going to create a new body and hit OK. And rename it to battery. So, and now I'm wondering, so we could create a group from those. New group. PCB. And I can select those and move them to the group. You can select the PCB as the group. And now it's in a hierarchy. Now let me see, can I... how to create individual components? I think this was not really needed. Okay, I moved a few steps back. So now I can save this, and actually I could save this as a new file. So let's see. And open up the Fab Academy 2020 demo. And now I can just move back in history and take the PCB and insert it into current design. And it's going to insert it as a component. And a component is an interesting concept in Fusion 360, because like a component has the same things that we had on the root hierarchy when we were building the object, so which consists of an origin and then bodies and sketches. So the most important part of the component is the origin, so that it has its individual origin, which is being used by the bodies and sketches inside the component. And then the component can be aligned to a root origin, to this another origin. So you see, so there's another one, so origin here, and then there's a origin inside the actual component. So if I do something with a component, let's say I choose to move it around, so like this here, so components, and I select this, and move it around, so it moves all the parts inside the component relative to this origin over here. And then, can I just show it? So I cannot really unhide it. And then whenever I do something in the original PCB file, so here the origin was hidden, so I can actually show it. And I go back here, so now it shows me that the original file was updated with this icon, and I can click on Get Latest, and it's also going to show the origin of the other file. So in here you can see that now these two origins overlap, but let's try to move this around a little bit. Hit OK. And you see that these are two different origins now. So each of these, so every component will have its own origin, and it's important. So you can build components of a bigger structure as separate files, and then you can have another project where you assemble those together. And then the individual files or individual components, you can move the parts within those constraints in their own universe separately. So yeah, now I just want to do, I'm going to go back and actually hide the origin here once more. And here I'm going to load the latest version. And now let's build a simple case around this. So when we have this object, so usually for parts like motors, it is possible to get step files from the website where you buy them from, or from part repositories, and then you can import these step files into your Fusion 360 model design and use them as references for designs. So in a similar way as these Fusion 360 files. And now, so let's just make a simple case around it. So for that, let's define some parameters. So wall thickness. Let's set it to 2 millimeters. And hit OK. Now let's create a new sketch, and let's create it on the bottom of the board. And let's include this bottom side. One more thing on top of these parameters, we could add tolerance between the actual object and the wall. Let's set it to 0.1. So that so we are going to have an inner wall and an outer wall. So let's start with the inner wall. So let's create an offset from here, and we can use the tolerance to offset it. So now if I zoom in, you'll see that there's a little space between the board and the line.
Sorry, what did you just, the offset?
Yeah, the offset. I'm going to use it again. So like this curve that I already offset. Oh, wait, there's some error. So modify, offset, ta-da. Okay, so yeah, it asks me to offset the original profile. So I'm gonna select this, and I'm gonna add tolerance plus the wall thickness, like so. Hit OK. Gonna finish sketch. And so one thing that I need to create is I'll extrude the bottom side of the box by using the wall thickness. And I don't want to start it exactly here, but I want it to offset by the amount of the tolerance as well. So here in the extrude, I will select the start position as offset plane, and in the offset I'm going to enter tolerance. So if I look from the side, you'll see that there's a small gap in between the board and the base. And I'm going to create a new body, that's okay. And then I am going to extrude the walls, like so. And as the extent, I'm going to choose the object or the bottom or the top of the board, like so. And maybe offset it or not. Maybe it should be this one, like so. And then I could make a cover that would then have these parts cut out. And one will definitely need to cut out something on the side in order to be able to insert the battery. So in this case, I can join those. So okay. Maybe before, oh yeah, so I don't want these to be holes over here. So if this happens, so we can go a few steps back. And so for the first extrusion over here, when we extruded the bottom part of it, I can double click and I see that. So in the, no, not this sketch, but there are other sketches over here. So I'm unhiding them, so I should select the holes as well here in order to extrude them together with the bottom plane. Like so, hit OK. And yeah, it nicely creates everything in the future decisions. There's one more thing that we didn't select the segment here in between, so we need to go back one more time. Yep, and we can select the in-between segment here. So now it's all fused together. Now it's fused together a bit too much. Wait a minute. Oh, this was actually good. At this point, like so, it will hit OK. But then the problem might be actually this one. Here for the profile, I will select only this outer segment, like so, hit OK. And if I view it from the top, then I should see a gap between the board and the wall. Like so. So I was talking about a battery. So let's make a hole here on the side of it for the battery. So instead of extruding, so let's create a new sketch here on the side. Then let's go and include the profile of the battery. Hit OK. Now we can create rectangle to cut out over here so that it actually matches the underlying design. And as we see that it's all black or constraint. So here, like next to the sketch, we see this little lock icon. So we finish sketch. And now we can use the extrude function in order to extrude it inwards, so it cuts out the edge a little bit. So, and for the extent, I'm going to choose object and select the inner face of the wall as the extent of it, and hit OK. And actually, if I'm thinking about how I'm going to remove it, I should also have it on the other side. And I would usually do it with 2 steps. So before cutting, I would create an object and duplicate the object on the other side and then cut both of those. But I'm going to show you a way how to do it with a feature. So you can actually mirror features. So you can go create, mirror. For the pattern type, you can select features. So these things here on the history line, yeah, these are features. And so for the features, I can select this extrude feature here. And for the mirror plane, I will select one of the original origin planes here. And it's going to mirror the cut feature on the other side, like so. So now what I want to do is create a cover. I'm going to skip these little pins here, so you can imagine how to create those. But I would be able to reuse some of the sketches. So I'm going to hide the bodies, and I'm going to create an extrusion from this one. And when this is selected, I'm going to unhide the bodies again. And for the start, I'm going to select an object, which is going to be the top face of the wall. And so the extent is going to be distance, and for the distance, I'm going to wait, I'm going to do it in a different way. So first, I'm going to unhide the bodies, also the board itself, and then I'm going to extrude. So it also matters from which side you select the sketch. Somehow, for some reason, it's pointing downwards, but I would like it to actually point upwards. So I'm just wondering why it's pointing downwards. But okay, it doesn't matter so much. I would like it to be a bit more clear. And then I'm going to unhide the board and unhide the body, so the enclosure, existing enclosure. And as for the start, I'm going to select an object, so the top face of the wall. And for the thickness, I'm going to enter the wall thickness. But in this case, I need to add minus in front of it. I wanted to avoid that, but this is what we need to do. There's a gap. And I want to create a new body. Hit OK. So yeah, for some reason there is a gap. I don't want it to be there. So what is it? So let's start profile. I actually want to start it from an object as well. I'm going to start it from here. Hit OK. And now it seems to be fine. I hide this. There's still some lines. I don't understand what's going on here. Wait. Because yeah, I want to join. Yes, like so. Yeah, so now I have this top here. And what now we want to do, we want to cut out the battery part. So I can see a few design flows already here, but it doesn't matter. So I'm just gonna cut out these. So create a sketch over here, and then I'm gonna hide this, create project include, this one, that. Okay, finish sketch, unhide the body, and now I'm going to cut out these shapes. So this, and then this and this. Why can't I select those? Extrude this, this, and that. And for the body, start is going to be the top part of the cover, and the extent is going to be the object or the bottom part of it. Just gonna hide this and select the bottom and hit OK. So now this is the case bottom and the case top. And then with this inside. So yeah. And then you can also specify some rendering elements for each of the things that you design. So for the PCB, for example, you could define the appearance or physical material. So let's make this to be something like bamboo. And then in order to see the materiality, we can switch, change the display settings. So visual style, shaded, environment. Where was it? Or did I really need into render? Appearance. Thought it was easier. Physical material. But for some reason it assigns it to all the object, not the individual body. But yeah, let's see if we go to design. It's still there. The LED could be something different. Yeah. Get latest. So yeah, to some extent you can control also the appearance, so there's more to it. I do not use it that often. Yeah, and then you even can do animation. So if you want to show some assembly instructions of the different parts, then you can do that and then export there's some animations. But now, so since we have this case, we can actually hide some parts to reveal the design here. And let's say that we want to 3D print it. Then we can go to Tools, then you hit on Make and 3D Print. And we need to select an object that we want to 3D print. So which is the outer side of the design, the bottom side of the case. And we can specify the mesh resolution. And we can output it directly to a 3D slicing utility like Cura or a slicer or Simplify 3D. But in this case, we're just going to output it to a file. And this is going to be like an example. STL. So an STL is the most popular, so kind of a standard for 3D, for storing files for 3D printing. So triangulated mesh. Hit save. And when I go here, hey, why can't I move it into the other screen? Because this is full screen. Here, and at least on Mac computers you can just click on the file and hit space and preview it. So in one of the following weeks we're gonna try to 3D print something like that, and that's another topic. So do you have any questions so far?
I'm very glad we did a separate course on this.
Yeah, so it takes some time to get into. Yeah, that's true. Sorry? Yeah, I mean, like, I'm not really showing it so that you would necessarily follow. I'm just showing this to demonstrate like some core concepts, like the practices that I use, for example. And then if you will need something specific, then you can just ask. Or there's tons of tutorials online about Fusion 360. And it's also constantly changing and updating, so it actually makes more sense to follow the tutorials there, like on the Autodesk website, than this. But yeah, so as for this demonstration, that's enough. What I wanted to show you is two other pieces of software. So one is OpenSCAD and the other is SolveSpace. So if we go to website, so OpenSCAD is kind of a programming environment, so where you actually create the design by writing code. So as I mentioned yesterday, it's nice if you want easy version control. And the benefit of this one is that you don't store the things on the cloud, you store it on your computer. You can version control it with Git, you can upload it then to GitLab, GitHub, or your own server, or just a floppy disk sometimes would be just enough to store the design file onto it. So it takes some time to get into, but the good thing is that it has this cheat sheet. And so if I zoom out, so it basically fits on one A3 page. And then if you would use it for a week or let's say a month, and you would go over all of these individual features, you would so you would kind of understand the core concepts of it, and you'll be able to model things. So what I wanted to show is how to design an outline of this in OpenSCAD. So just to demonstrate what it is capable of and how it works. So I'm going to open OpenSCAD and create a new file. And The nice thing about it is that it's parametric in terms, because like you can add variables as in any other programming language, and it looks like this. For size X is going to be 50, so Y is going to be 20, and then hold is going to be 1, then offset from the edge is going to be 2.5, and then for the board we need also corner radius, which is going to be 3. And the way how you do things here is you execute a command, which is a function, and here I think you use so let's take a look at them. So radius or diameter. So let's take a look at the circle. So the parameters. So it's good to use the names here. So the variable names, assignments, not just use parameters alone, because it has evolved during the last years, and because of some legacy issues, it's better to use the names. So it's going to be corner. And you still need to use this semicolon here. I hope that in the future versions they are going to remove this. And yeah, also here in the variable definitions, so it throws errors because we actually need to use semicolons at the end of the lines. And here it is. So you write this one line of code, and then you get the object visible over here. And what is really nice is that, so it wasn't here previously, but there's this customizer or the parameter pane over here. So where you can see all the parameters that are in the design, and you can save parameter presets even. So you can, let's say, enter 60 here, hit enter. It doesn't change, you see, it doesn't change in the file, but then here, let's see, test. Can I save a preset? Automatic preview. Reset. Okay. All right, now it's reset. Oh, I thought it's gonna work, but it doesn't. Yeah, whatever. So there's something buggy. So this is what I see the first time. So in the previous versions of OpenSCAD, it didn't have this parameter pane. But then I think it makes it easier to experiment with some parameters, even though you don't want them to change here. So just to see what are going to be the effects. So yeah, so this circle, it's kind of very polygonic, so very meshy, so to say. So if you want to increase its fidelity, then there are some special functions for that. So you can check them here. So in order to increase the number of fragments, you use this variable over here. So it looks like this. So 36. I'm going to save. No, not save, but render. So there are these two buttons up here. So this dashed line button, it's for preview render, so it's faster, and then this is for the final render, which if you're building a complicated object, it's going to take longer, but then this is necessary in order for you to be able to export the mesh and so on. So since these are corner circles, so we need to kind of align them somewhere in the corners. So let's do that, and for that you use the translate command. And things like translate and also extrude and also Boolean operations work in this way. So you use the function, and then as the body of the function you are defining the actual drawing. So now translates here. So yeah, this is the argument that you would use. So v and we are going to translate it by board. So board size X divided by 2, and board size Y divided by 2 as well. And I'm going to call this as, no, so like for now I'm going to leave this like it is, but one thing about it is that it makes sense to create all these snippets as modules. So like you can create functions of objects, like for drawing objects, because this can kind of create quite a mess if you repeat those, like 5 of those after each other. And sometimes you just want to repeat things. It happens actually quite often. So this is where the concept of module comes in. So it's kind of a function definition, but function and module is two different things in OpenSCAD. So function you would rather use for some parameters if you want to change, if you want to use that for mathematical operations and so on. But modules you would specifically use for drawing. Correct me if I'm wrong, but it seems so. Functions operate on values to calculate and return new values. And then if you click on module, then its modules can be used to define objects. So let's create a module out of this. So module, draw hole, and let's put it inside these curly brackets like this. And now if I will hit render, then it's going to render nothing because we are not using